What's up, my Algebra 2 homies? Mr. Miller here in the house, bringing you another video on Algebra 2 concepts. I'm really psyched about this. What I want to do is take an example that we already saw in the previous video, and I want to explain it a little bit more in detail, because to first hour's credit, a few people asked me some questions about how am I getting these numbers on the side of the box or table and above? How am I getting these numbers? Why is the GCF of 3 and 6 3? Why is the GCF of 5 and 10 5? I'm ignoring the negative for now to keep it simple. So that's what I want to do in this video. I want to clarify how am I getting these numbers. Now, I want to say that you want to eventually get so good at factoring out these GCFs that you're not going to have to use this supplemental method that I'm about to show you. But for now, to help you get by, you can use this method, and it will very rarely lead you astray. I can't talk today. Sorry. Okay, it is still early in the morning. It's like 8:30 right now, and my coffee hasn't kicked in. Now, let me demonstrate what I mean by this. How are we getting these GCFs? Let me switch to the pen and we'll work this out together. Let's pretend for a moment that we haven't filled in the sides of our table and the top of our table yet. Let's pretend that those numbers and letters aren't even there yet. Why is the GCF of 3 and 6 3? Okay, so let's say that you're trying to figure out the GCF of that, and you're like, I have no idea what the GCF is. My world is coming to an end. I'll never figure it out. Quit being so overdramatic. It's not that bad, is it? Well, maybe it is. I don't know. What I would do first is list the numbers of the row or the column that you're trying to factor the GCF out of. We have 3 and we have 6 in that first row, right? And what I want to do is I want to think of all the ways that I can multiply to get 3 using whole numbers. Okay, 1 and 3, that's obvious. Any other ways to multiply to get 3? Don't think so. Okay, how about 6? 6 is 1, 6, and 2 and 3. All right, now, what is the biggest number in both of those charts or tables, whatever you want to call it? And by the way, I want to say it doesn't matter if the number that is matching is on the left or right side of the table. For instance, here the 3 is the biggest for both, right? But notice that they're both on the right side. What I'm trying to say is it wouldn't have mattered if this 3 would have been on the left and this 3 stayed on the right. You see, it doesn't, the sides of the table don't matter. You want to treat the table as a single thing and compare it to the other table and pull out the biggest number that matches, and that's going to be your GCF. And that's why the GCF of this first row is 3. Now, let's do 5 and 10 now. 5 and 10, because that's our bottom row, right? 5 and 10. I'm in a singing mood today. What are all the ways to multiply to get 5? 1 and 5, right? How about 10? 1 and 10, 2 and 5. Isn't my voice beautiful? Nah, it's not. I better keep my day job, right? All right, what is the biggest number that matches in both of these here tables? 5. And again, it looks like that we're setting a precedent here. It looks like, oh, your number, in order for it to match, it always has to be on the same side of the table. Right side, right side. Hey, listen, if I wanted to, when I did this table, let me do 10. I could have written my factors like this. I could have done 10 and 1, and I could have done 5 and 2. The order doesn't matter, right? Because look, 5 times 2 is still 10. And 2 times 5 is still 10. So the placement of the numbers in the table, as far as which side you're putting them on, it doesn't matter, right? So I'm just trying to say I don't want anybody to think that in order for you to pull a number out of the two tables, they have to be on the same side. That's not the case, all right? I hope that's clear. If it's not, call me over and I'll try to do a better job of explaining. Okay, so that's why the GCF of our, hang on a second. Sorry about that, but there was a knock on the door. I had a visitor. Somebody in one of my classes was a bad boy. He's in the biz. I won't mention any names. All right. Let's. Now I've got to remember what we're talking about. Let's see. We did 5. Let me go back to that. All right. So that's why the GCF of this bottom row is 5. And then, of course, the reason why we put a negative there is because we take the sign of the neighbor. Our neighbor here is negative, so that means our GCF will be negative. Now, here's the cool thing. When you go to do the GCF of the columns now, or if you would have started with the columns first and then went to the rows, basically all of your work is already done for you in these 4 charts. We don't have to do this, okay, let's list 3 and 5 now and get their factors because look, we already did that. We already have the factors of 3 and 5. And what's the biggest number that's the same in both tables? It is 1. Beautiful. All right, how about 6 and 10? Let's take a look at 6 and 10. What's the biggest number that is a factor of 6 and 10? Well, that would be 2. Okay, so that's why when we went over to our column here, I pulled out a 1 and I pulled out a 2. All right, I hope that's helpful. If it's not, I'm sorry, I'm doing the best I can. I've never really done these video lectures before until this year, so there's a learning curve there. I'm trying to get better. If you have any suggestions for me, feel free to shoot those my way or tell me directly, and keep up the good work. Okay, that's it. Adios.